Hello, I'm going to do some problems from chapter 14 today, which is the quality control chapter. And the first problem I'm going to do is problem 14.1, which is from section 2 of the chapter. 14.2, problem 1, and it's a control chart for the proportion, or it's also called a P chart. The particular problem that I'm doing is found on page 14-9, and it's problem 14.1, as I said. We've collected some data on nonconformances for a period of 10 days. And nonconformances just means these parts were not satisfactory. We weren't able to use them. In this particular example, you'll notice that the sample sizes are all the same. We've got 10 days on which we took observations, and we've collected data each day to find out of 100 observations, how many of those were good or bad. So the question says, on what day is the proportion of nonconformances the largest and smallest? And since our sample sizes are the same in this case, it's pretty easy to just look at the highest number, which would be 22 over 100, or 0.22, 22%, would be the highest value, and then the smallest value would be on day 3, which is 10 observations. So the answer to part A is, well, here we are. On what day is the proportion of conformances largest and smallest? Day 5 would be the largest, 22 out of 100, and day 3 would be 10 out of 100. Now, if you had a differing sample size, you'd have to actually take the value for X, or the nonconformances, and divide by N to make those into proportions. Then you could compare the values. But in this case, because the sample sizes are all the same, we can just examine the numbers for nonconformances themselves rather than having to do the proportion. Okay, then it says, what are the lower control limits and the upper control limits, and are there any special causes of variation? So here's the formula for the lower and upper control limits for this type of problem. So the first thing we did over here, one of the things you could do, is just calculate the proportion, which is what this last column is over here. And so you just take 12 over 100 to get 0.12, 14 over 100, 0.14, etc. So there are the proportions. And then to find P bar, what we do is we add up those 10 values. We get 1.48, and then we divide by the sample size, which is N for each day, which is 100, and that gives us 0.148. So that's our average proportion is going to be 14.8%. And then we add and subtract the square root, or 3 times the square root of P bar times 1 minus P bar over N bar. And so we plug in the values for P bar, and 1 minus that, and N bar is 100 because all of our sample sizes are equal in this case, and they're all equal to 100. So therefore, we end up with an upper control limit of 0.2545 and a lower control limit, by using the same formula and subtracting, 0.0415. So that's the answer to part B. The upper and lower control limits are 25.45% basically, or 0.2545, and lower limit 0.0415. So both values are positive, so we would need to examine both values to see if we have any special cause of variation. The answer to that, are there any special causes of variation, is, since all proportions are within the control limits, no special cause variation exists. How do we know that? We can just compare these values in this last column with the lower and upper limits. Are there any greater than 25? 0.25? No. Are there any less than 0.0415? And the answer is no. So that's how we know in part C there is no special cause variation.